This is the final testing of 41443. What I do on a lot of these items that have intermittent audio, I make this quick video. It's no greater effort on my behalf. I just push a button, move the camera. It has to be tested anyways. And it helps the customer understand some of the procedures. What we're going to do is feed in a steady state signal, a 400 cycle sine wave into one of the inputs on the back. And we're going to view the output on this device here. And let's see if I can zoom in on this a little bit. This is a dual trace oscilloscope. If I get the light off it, you can see the traces better. Actually, it's too bright now, but let's turn it down a little bit. That should be okay. The upper channel is going to be the upper horizontal line is going to be the left channel. The lower horizontal line is going to be the right. And simultaneously on this device, this horizontal black piece, that's a bar graph that measures distortion, power, frequency response. The left channel will also be displayed, and the upper bar and the right channel will be displayed on the lower bar. So we're going to back this out and get us a little more light here. So what I ended up doing was we soldered heat stress connections, the oxidized switches and controls, but I think one of the primary offenders was the speaker relay. Even after I rebuilt the relay, I still was not satisfied with its reliability. So it was replaced. And while I have the light on, I'll show you what this new relay looks like. The original stock one is garbage. So we'll replace it with a relay that Sony uses, which is, this camera's on this gooseneck thing. It's this blue rectangle, right? Right there. That pretty blue thing with the white is the new relay. And what I'm going to do is, when we feed, that right there is the new relay. So much for autofocus. We're going to be tapping on that when I feed in the sine waves and watch it on the oscilloscope. If the relay is bad, tapping on that will show the waveforms breaking up or disappearing totally on the oscilloscope. So what we're going to do is, whoa, let's get focused on the oscilloscope. You're going to turn on your item. And if this is too loud, if it's too loud, I don't see it at all. And this is unrehearsed stuff here, folks. There we go. If this is too loud, it's going to, let me turn the speakers on. If this is too loud, it's going to distort the microphone. So what we're going to do is, there we go. What we're going to do is switch the speakers into what's called a dummy load. Dummy load stresses the amplifier the same, but it doesn't damage my ears, distort the microphone, or blow up speakers. So we're going to go over to the dummy loads. And I'm going to take the balance control and go to the left. Notice the bottom display disappears. Go to the right. The top display disappears. I'm then going to go to that relay, and this is the acid test for the relay. Tapping on this relay, and if you look at the oscilloscope, which it's rock solid, and we can drive the item to full power. I don't like to do that for too long or we blow it up. But this item is now rock solid once again, and nothing that you did caused this. I'm finding that this particular type of relay that Fisher used in this series becomes unreliable, and I like to replace it with this blue relay that Sony uses. Okay, So we're going to wrap this up and put it together, test it one more time, and then send a completion email. That is the end of this test.